RUP graduation ceremony is now. Um, can you make a time from 9 to 9:30 there? Yeah. Or even like 9.
Hi everyone, so we're gonna start our ceremony today. We're gonna wait like 1 more minute, then we have officially started our closing ceremony of our summer camp and our final presentation. Okay, let's get started. So hello everyone, welcome to join our RUP Summer Camp Environmental Summer Camp closing ceremony and the final presentation. So I'm the host Andy, and I'm be with Scully to hosting this ceremony with everyone. So we appreciate it. So first, we welcome to all the people joining us, especially for the coaches and for the 5 judges. So welcome you to join us and doing your delegation work. Especially for the 5 judges, you'll be the final doing the final evaluation for our students' work. And we are so excited all the students can join us today and to share what you're doing for the past 6 weeks. Your delegation work will be so valued, and we want here to share with you and give you applause. So first of all, we are gonna to introduce our 5 judges because they're here to helping us for today's evaluation work. So I'm gonna share to Scully. If you wanna wait a second, let me change the slides. Oh, yeah. Okay. Oh, sorry. Before we introduce the judges, I'm gonna share the ceremony agenda for today. So for all of you students, you have to get ready. So the first, we're gonna have the PFAS group presentation. The team member will be Claire Xu, Emma Zhong, and Tony Ning, and Ingrid Law. And the second, we have a water conservation, California native plants, and your group presentation. Also, these groups have so for this group you have a 2 presentation. So the first team will be Kathleen Lin and Dory Meng and Melissa Meng and Daniel Wu and Yimeng Yuan, and the second team will be Jingyao Zhang and Jessica Wang and Maggie Wu and Emily Lei and James Lai and Garrison Gan. And the third team will be Surface Water Manager team group presentation. So the team member will be Alexander Meng and Erica Wang and Erica Toy and Justin Hall. So the first team will be microalgae and water treatment group presentation. The team will be Mark Poor and Daniel Chu and Gary Xu. So the last team will be massing in groundwater group presentation. So the team member will be Jason, Eric Song, and Zachary Gay, and Howard Ye, and Karina Miao, and Angela Ling. So please prepare, and we'll be following this order. So each team will have 10 to 15 minutes to presenting your work, and you also have 5 minutes for the question now, and we'll be following the order, and I will be here to give you a mention if the time is almost there. So next, we're gonna welcome I'll go to the scholar to introduce our 5 judges. Yeah.
Okay.
Andy.
Thank you, Andy.
Andy,
Oh,
before
wow,
you
go ahead.
start, can I say something?
Okay, of course, sure.
For your methane in groundwater session, we do have more team members. Our report is in 2 sections. You'll probably miss the second section. The second section, the team members are Wenxi Li, Sean Li, and Tony Wang. Okay, please add them into our program.
Okay, sure. Okay, got it. Okay, so because we have only have like short time to we already sent an announcement for everybody to send me the slides by end of yesterday. So I guess I didn't receive their slides. So I'm sorry I didn't put the name in here. So, but no problem. We will be putting there since your teams will be the last.
Please
Okay.
put this 4 names in there.
Okay. Yeah. Sure.
Dig into a file and please put in there. Thank you.
Okay, let's transfer to with Scully. Yeah.
Okay, I'll take it over. All right, here we are, guys. First, I want to congratulate you all for completing this summer camp, all the sessions. I'm so proud of you all. I heard some good words from some coaches. It's a fun experience, and I also participated in a couple of the field trips. I had a fun time myself, and I believe you guys also did. And today is a big day. You're going to make it to the final presentation. And we are also very grateful that we have 5 excellent judges from the different fields in environmental industry. I'm going to introduce them in the alphabetical order of their names. First is our Dr. C.Y. Zheng or Sean Zheng. CY, can you turn on your camera? CY is our SCAPA. SCAPA stands for Southern California Chinese American Environmental Protection Association. SCAPA. CY is our current director at large, and he's a toxicologist in the California State Department of Toxic Substances Control. He carries many years of experience in this field. I'm not going to go to the details. You can, if you're interested, you can read into his brief introduction on the slide. And next we have Dr. Guojing Liu. She's currently the improvement manager of Dow Chemical Company in Texas, and she lives in Texas. So we must appreciate that she's in a different time zone. Right now there, it's 9:10 p.m. in their time. So we really appreciate Dr. Liu giving us such a valuable time.
iPad.
Andy, can you please mute some of the audience? About, yeah, hear some noise. Yeah.
Thank you.
And then next we have Dr. Elaine Shen. She's currently one of the board members of SCAPA, and she's the program supervisor at the Southern California Air Quality Management District, also government employee. And she has experience on economics, and she got her degree in Belgium. Yeah, that's Dr. Shen. And Andy, can you go to the next slide? And we have Dr. Lei Xu. Dr. Xu is currently a professor at Cal State Fullerton. She got her PhD in geography, and she was served as the executive president of, she's currently the president of Boya Foundation, and she was the chairman of the Peking University Alumni Association. That's Dr. Xu. And we have Dr. Zhong Xiong. He's currently our vice president of SCAPA, and he's the practice lead of PFAS. One of your groups, you guys are studying a lot on PFAS. So now, Dr. Xiong will be the best expert to understand you guys the most. Okay. So now you guys, you can see our judges, they come from either the university or industry or government employee. It's a variety of background, and we are all here to hear you guys share with us your learning and the exciting things. So we can't wait to hear that. Andy, back to you. You're muted.
Thank you for Scarlett to introduce the 5 judges. Okay, now we are officially entering our presenting time. So first we're gonna inviting the first team, the PFA groups. So are you ready? If you're ready, I'm gonna stop share and you can start to share your screen and to present. Yeah.
Andy, this is Jeffrey. I'm the coach of this team. And I just want to say a few words before Claire start presenting.
Yeah, hi, Jeffrey.
Yeah, so my group, we basically have like 4 teams working on different topic related to PFAS challenge. And we have a professor team. We have a future senator team, and future lawyers team, and future chemist team. So students were grouped into 4 teams and assumed the future role of leader in their professions. Because PFAS has been a social challenge for not only America, but many countries in the world. And it does take a village to address this social challenge. So I basically, presented a different topic for students to, develop their interest and face up the challenge, and hopefully to sort out solutions. I told my students, as a future leader, they need to do their work, not expect a lift from the coach or parents. And I presented the challenge topic for them. They got the list of references provided to them. Then they work on the topic, the exercises. And in the end, we picked the lawyers team to present, but it doesn't really represent the whole effort for the whole team, the 4 teams, to address this social challenge collectively. And just simply join the team does not make a leader. A leader is not born. A leader is made through hard work. And just like Vince Lombardi said, okay? So I'm so proud of our students here, and Claire, Emma, Tony, Ingrid, and you guys demonstrate you guys are the leaders. And I cannot tell how much proud I am. I'm ready for you to present, and also to our judges. those students were doing their project using their little mind, bright mind, to look at the problem, go through the problems, and figure out a way through their own bright mind. I did not give them any help. And that's basically what I told them. I'm not going to give them any help. And you are the leaders, figure out a way to address the problem. I think they did a great job, and they not without struggle. And I'm hoping that the judges are realize that this are not a super academic, super technical, but it's the idea to face a problem, to address a problem, to figure out a solution that count the most. And I did also invited a lawyer from actual law firm from Alice downtown, and also a postdoctor fellow from Caltech, give them their own lectures about the corresponding topic for professors and for the lawyers. So Claire, please, without further ado, and you got 10 minutes. It took some minutes of yours. Thank you.
Okay. Hi everyone, I'm Claire and I'm here to share our final presentation as a lawyer. Do I have Emma and Tony here to introduce themselves real quick?
Hi, I'm Tony and I'm a part of the professor group. So basically, what is PFAS? PFAS is an umbrella term for over 4,000 chemicals, and they were introduced to the US in the 1940s. They are very persistent in the environment and in tissues because they're basically indestructible and they can withstand high temperatures. This means that PFAS, once they're in the environment, they can bioaccumulate and biomagnify through food chains all the way to humans and cause adverse effects in living organisms. Because they are nearly indestructible, they were nicknamed the forever chemicals. And right now they're seeping into groundwater and contaminating clean drinking water, which is negatively affecting human health. Yet there are no strict regulations in California yet. Wastewater treatment plants in California also don't specifically treat water to remove PFAS because there's no strict regulation. And on the right, you could see that PFAS can be found in many products such as nonstick cookware, shampoo, paints, and just to mention a few. Okay, you could go to the next slide. And PFAS is a man-made product. You can see that they are produced in factories and can get discharged through wastewater into water, which can seep into groundwater. It can also get discharged through air. And that eventually can reach us, which were basically, we also use PFAS treated materials, and that can also basically poison us. So PFAS, the forever chemicals, are seeping into groundwater and contaminating the drinking water. And plants and animals who rely on this water are going to be poisoned as well. And this can move through food chains. And they're being released into water and air and deeply affecting our health. But with no strict regulation, there is so basically, as a professor, I would like to have a way of basically finding an MCL or maximum contaminant level to make sure that there is not too much PFAS in water wells. And you could go to the next slide. So my job was to write a grant proposal to NSF, National Science Foundation. So we included things like $1 million to buy equipment and collect data from water wells all around California, and to determine a proper MCL to make sure that there's not too much PFAS. And we could also use more communication about PFAS, so we can establish a system to notify the PFAS level in drinking water. And then also travel around to notify people about PFAS contaminating our water to show that this is a problem everybody should be aware of.
Okay, let me give you guys some background information of our case first. So the manufacturer 3M, which applies PFAS to their products, dumps the contaminated waste into the natural environment. PFAS is a part of the same family as PFOA, PFOS, jinx, man-made chemicals known to have detrimental health effects such as increased cholesterol levels, changes in liver enzymes, increased risk of high blood pressure, and also increased risk of cancer, decreased infant weight, decreased vaccine response in children. So what if 150 local water purveyors supply contaminated water? Let's view this question as a lawyer with me. First, as Tony mentioned before, the impact on the environment. PFAS can enter the environment through production or waste streams and are very persistent in the environment, affects the soil, wildlife, livestock, and crops. Eventually, these chemicals will travel into human body. Exhaust streams, which contains PFAS, run into the ocean. It will place marine life in danger as well. So, objective view, the case is definitely going to cost a lot of not only money, but also time and manpower. However, the outcome is surely positive to human society and the environment in long term. If we get it going, the rate of cancer in human would decrease, livestock and crops would bring better harvest, and human well-being and economy will become better off. In short run, some industries with PFAS disposal will face difficulties. And this is my cost claim as a lawyer position. Okay, according to a water usage report, around 4.5 million gallons of water are used by a single well annually. In this case, 150 local water purveyors supply 675 million gallons of water to around 60 houses per year. If we have to shut down these water wells for 10 years to treat PFAS, there would be a revenue loss of $10 million in total. Furthermore, the case budget will raise to $50 million, including compensations for lawyers, chemists, and other necessary expenditures. All right, Tony, would you draw the conclusion for us?
Sure. So our projects will not, if it were to come true, it would not only make water safer for Americans, but also inspire other scientists around the world to do the same. With countries like US and Japan starting to realize this problem and banning PFOA and PFOS, many Asian countries like China and India are still don't have any strict regulations on these chemicals. And these are getting more and more popular and getting more manufactured. So this is only the start of getting rid of PFAS, as these ideas can travel around the globe to fix these problems to make drinking water cleaner and safer for everyone.
All right. That's our final presentation. Thank you, everyone.
Excellent job.
Thank you, PFAS group. So we have like 5 minutes. If the judges have like any question, want to asking them, now is your time.
So this is Gerjun. I have a question. What is the specific objective of this project? What is this group of people trying to achieve to perform this project?
I'll take that question. Like I said at the very beginning, PFAS has become a social challenge for America among many other countries in the world. And I'm trying to encourage the youngsters to pay special attention to the environmental issues and as the future leaders in their career or profession, and try to figure out play an active role to address a social issue like PFAS that bring the challenge to all of us right now. So they could be a professor in college and try to help the state to figure out what's the best way to determine the MCL, to get secure some fundings from National Science Foundation, and also as a lawyer, like a prominent lawyer in a law firm, to try to sue the manufacturer of the PFAS chemical group, like a 3MM, clearly that's a fictitious name. So
Jeffrey, I can tell you're a great coach. You're a great coach. You give a great introduction of the team's objective at the beginning.
Yeah.
Can we have some of the students help answering? Because this is really, we want to see how the students learn from this whole process.
Yeah, Claire, go for it.
Thank you, Jeff.
Sure. So our goal is to, like, as our coach mentioned before, we have 4 different roles, and our goals is like for students to perform as these roles and to seek for possible solutions to the PFAS problem. So in today's presentation, I'm presenting as a lawyer and Tony was presenting as a professor. So Tony was supposed to give us like a brief plan about how a professor should look for possible ways to get rid of PFAS in contaminated water. And I'm supposed to give like a case of like convince people to, put this action like really in place. Yeah, I think probably that would answer your question.
Okay, thank you. So what kind of information do you think you need to collect in order to persuade people to take actions?
Okay, so we first have to alarm people of like how important this is. Clearly, like it's affecting our not only human health, but also the environment and eventually the society. So we have to first alarm people with these things. And then we have to like give a plan about like how much budget we need to get it going and how many manpower, these kind of things. And then we're gonna give them like a specific plan about, like a timeline, what to do in this month and what to do in next month, and finally get this plan going.
Okay, can I just add a few notes? I understand that some of our students are very curious about this topic and they want to ask questions. Can we give the opportunities to our judges first, and then if we have time, we'll allow some questions from the students. And each team, when you answer the questions, I hope to hear the answer from the different team members, okay? Because we want to see the teamwork. Okay, not just one single person addressing all the questions, because teamwork is going to be one of the criteria we're looking at, the judges will look at. Okay, I think some of the judges have questions.
Yeah, thanks, Scarlett. Yeah, I do have a question. Yeah, Claire, you mentioned there's a 14. I think some of them mentioned the other two other teams.
Okay, I'm very sorry to interrupt.
So I'm curious, what's the other 2 team and what's the topic that the other 2 team worked on?
Okay, so we have senator team and the chemist team. The chemist team is supposed to find like, in a chemist view, like how to treat PFAS. And then the senator is supposed to write a report to the federal, like to convince them to publish a regulation or a law against PFAS.
Okay, looks like Elaine
Cool,
has a
that's
question.
that's very
sorry.
interesting. Thanks for the answer.
Of course.
I just wanted to say kudos to the team and also like team members playing different roles. And so as when Scarlett introduced me, you know that I used to lead our socioeconomic impact assessment team at the South Coast AQMD. So when I look at the coast climb, the slide, then it kind of reminds me of what I did in the past. And so I think I'm trying to figure out that, like, as a lawyer, when you list the coast claims, are you trying to say like how much damage the PFAS pollution could be to the community, or are you trying to tell people how much it will cost for them to shut down the well, and then also how much they will have to pay the lawyers for? I think I'm kind of trying to figure out what you are trying to convey in that slide. Like, are you trying to tell people how much they have to pay the lawyer, how much damage they have to pay in terms of health damages? Like, what exactly is that?
I think, sorry, I think both. Like, I think I include both of them there, because if like they don't take actions, the cost would be the danger it brought to human health and society well-being. But if they choose to pay for the case and then like publish something against PFAS, the cost will be the compensation for lawyers, chemists, and all these expenditures. So like I'm comparing these two costs, and it seems that like paying for lawyers and chemists to fight against PFAS would be a better choice, like, to convince people.
So you are a lawyer on the side of the people whose health will be damaged because of PFAS pollution, or are you on the side of the industry?
I'm on the side of the human health, like the society well-being. Yeah.
Yep. Thank you.
Okay, for this group, the question will be end up. So we're going to next group. So next will be the water conservation, California native plants, and your group and you. So we'll be inviting the group 1 is Kathleen Lane, Doreen Meng, Melissa Meng, and Daniel Wu, and Yimeng Yuan. Yeah, please share your screen.
Hey, Andy, this is Coach Yiping and Coach Donna. So I just like to say a few sentences to give a little bit of background.
Of course, sure, yeah.
Yeah, so number 1, so our theme, our class, so we just wanted to say that we actually, our goal is the presentation will not be about research. The students are actually given a design project. So to design a garden. So you will not see problem definition. We're not trying to solve anything and finding a solution. So that's one background. The second thing is that I just want to say, we, both Donna and I, we give the student freestyle in terms of what design theme or goal, theme or goal they're trying to achieve through the design. That's totally their choice. There's no mandatory prescription from the judges. So you see that would be really different. The other thing is that in terms of how they present the design sketch is also freestyle, and whatever they choose, as well as the presentation style, how they choose to present it is also freestyle. So just a little bit of background on that, and so the judges are not surprised.
Right. The goal is, well, we talked about water conservation and how to use native plants to help with water conservation, and how you can design a landscape using that to expand the use of those plants and also expand water conservation throughout the neighborhood if everyone starts changing. And it can be any kind of property. It can be a house, or it can be a schoolyard, whatever they like to choose. Then they need to research what's required to make that garden successful, such as what unique properties, like how much sun, how much shade, how much conditions the soil have to be in. So they had to find all that on their own and make that selection of the goal and do the research to come up with their design.
Thank you, coaches, to clarify. Okay, so before we started, I have an announcement for the rest of the groups. So when you're presenting, please open your camera in order to have your better performance. So yeah, and to respect all of us. Yeah. So so we are inviting the first team. Kathleen, can you you're ready to? We are ready. Please share your screen. Yeah.
Hello. I'm so sorry. One of our members, Daniel, I think he has some internet issues. So do you mind if team 2 can go first so that Daniel has time to hop back in?
Oh, okay. Yeah, no problem. So now we're inviting the team 2.
Yes.
So
Okay. Thank you.
okay,
Oh.
Jing,
Hello? Is anyone there?
Actually,
Hello?
I
Hi.
think Daniel might be on. And team 2, there's one person, Andy. Remember, I was telling you, I don't know if that person is on or not. She has
Hello?
another.
There.
Daniel, is that you?
Yeah.
Yun
Ma-
Shang. Okay.
Hello?
Daniel's here.
Hello? A blackout just happened. And I have no idea what happened. But now you guys are very
I'm sorry, Daniel, we can hear you.
laggy. Well, not that laggy, but sometimes like happens. And I can talk about it any second. Anywho, that's my work. You can't or can't.
Andy, if
Hello?
if both of the two teams of this group cannot do it now,
Hello?
can we?
That's okay.
Can we move some other teams up ahead?
For team 1, I can take over for
Can
Daniel. if
anyone
that's
hear
okay.
me?
It's not clear though,
Hello?
but maybe we can have team 2 go first, and then that would give Daniel a chance to sort out the technical issue. Would that be okay?
Yeah, that's fine. Thank you.
Okay.
I am so sorry. I'm actually Daniel's sister, and I'm in team 2, and I'm actually supposed to share my screen, but I have a blackout too. So is this possible? Can one of the coach share our slides, if that's possible at least?
Wait.
Please share your slides. Yeah, no problem.
Okay, that's great. Thank you.
Okay, you got it. No problem.
Can you hear me?
We can hear you, Daniel, but it's not clear. It's cutting in and out.
Yeah, hey Daniel, can you do you mind use your sister's microphone when you're presenting, because it's keep coming back and forth, and thank you.
Yeah, I can let him my phone. Yeah, that's fine. Can you guys hear me clearly or no?
Yeah.
Yeah.
We can hear you
So
very
is
clearly.
team 2 going first or team 1?
If Daniel's ready, we can have team 1 if he's going to use your microphone, but I don't want to lose
Okay,
any
yeah.
time here.
Yeah, sure.
If you're,
Here.
Daniel, are you ready? If not, we'll go to team 2 first.
Okay, yeah, he's right here. All right,
Okay.
hey guys, sorry, a freak blackout happened, so now I am here.
Okay,
Wait,
good.
but
We'll
isn't
hang
your
in there. We'll
team
go with
you-
team
Oh,
2
okay.
and Japanese garden first.
All right, team 1 will be starting first, right?
Team 2 is going. Their screen's up, so just hang in there, Daniel.
Oh, all right. Says teams 2. What? Oh God. Okay. Oh my
Okay.
God. Okay. Okay, let's start. Sorry. Here, let's start.
Okay, hi
go ahead.
everyone. Oh, and this is team 2 from like water conservation group, and our project is to plant a Japanese garden, and this is done and presented by me, Jessica Wong, Maggie Wu, James Lai, Emily Lai, and Carson Gan. And to start off, oh, please, next slide. Thank you. To start off, our group will introduce the property sketch with the description, the landscape goals, and a special scene. Then we will present our soil selection, soil additions, and the plant selection slides. Finally, we will show the final garden sketch and the summary. In addition, there is a resources cited page. Next slide, please. After multiple discussions and Zoom meetings, we decided to use Emily's backyard. Emily's backyard is vast, giving us plenty of space to arrange the plants. Her house is located on the bottom left corner if looking at it from the bird's eye view. And because her garden is so large, it has full sun exposure. Her garden has a Mediterranean climate and the soil of a pH of 7 to 7.5. Her yard includes 3 rock paths, a pond, and a bridge, perfect for our chosen theme, a Japanese and an Asian style garden. Next slide, please.
So as stated by Jing Yao, our garden theme is Japanese and Asian styled. Also, after research and careful selection, the goal for our plants in the garden are all low maintenance plants. Next slide, please. Since I live in a Mediterranean climate on the Palos Verdes Peninsula, the soil here tends to be pretty dry due to the local soil type, sandy loam. This soil type is defined as having significant amounts of sand particles along with some silt and clay particles. Sandy soil is well drained since sand particles don't clump together well. This also means that sandy loam does not retain a lot of water. So if you planted flora that needs to be watered frequently, such as roses, then you need to water them at least a few times a week, which is not water efficient. Furthermore, nutrients don't tend to hold well in sandy loam either, so we decided to use fertilizer. Also, since this is SoCal, full sun to partial sun exposure is expected. Since I live at a relatively high altitude, there are higher chances of full sun exposure because I live above the usual cloud cover. Next slide, please. The soil here can lack nutrients. Therefore, I chose the Espoma Organic Tradition Soil Acidifier. Its main elemental component is sulfur, which lasts a really long time in the soil, even though it takes longer to set in. Although it is not needed for alkaline or basic soil plants, the acidifier will help plants that prefer more acidic soil. In addition, to increase soil fertility, I chose shredded bark, a mulch which does not block the airflow to the soil. Since shredded bark decomposes easily, it can provide nutrients on a more frequent basis. Next slide, please. Azalea, or in scientific terms, rhododendron, is a type of shrub native to Japan and Korea that is 3 to 5 feet tall with trumpet-shaped flowers in colors yellow, red, pink, white, and more. Azaleas can be exposed up to 6 hours a day and need a well-drained acidic soil with a pH of 4.5 to 6.0 to survive. Because the soil we use is not that acidic, we had to add the sulfur acidifier to the specific area where azaleas are planted to increase acidity. Next slide, please.
The water lily, also known as the nymphaceae, is a type of aquatic perennial that is usually less than 6 inches tall with unique shaped flowers that can be found in red, pink, and white. The water lily thrives when exposed to full sunlight and the clay loamy soil with a HP of 6.1 to 7. Water lily prevents algae from growing in ponds because it shades the pond, thus decreasing the need for frequent water checkups. Next slide, please. The wisteria plant, or Wisteria sinensis, is a type of flowering plant that is native to Asia and North America. This plant can be found in height 10 to 30 feet in colors from bluish purple to white. The wisteria plant grows best in full to partial sunlight and needs well-drained soil with an HP of 6 to 7 to survive. Keep in mind the plant is very adaptable when it comes to HP levels. Although wisteria may be an invasive plant, we planned on putting a fence around the garden to stop mammals from continuously spreading the seeds of wisterias. Wisteria trees also attract an enormous amount of bees, which makes it a bee sanctuary. Next slide, please. The giant cane, with the scientific name being Arundandria genotilia, is a type of bamboo that is native to North America and is usually 1 to 8 meters with the color green. The giant cane grows best in full sunlight with moist soil with a pH level of 5 to 6. Although the giant cane is invasive since its roots spread rapidly, it can be kept under control with bamboo barriers. Next slide, please. Duckweed, or in scientific terms, lemonade, is a type of flowering plant which is native to Africa, Asia, Europe, and North America. It consists of a light green color and thrives best in full sun exposure with a water pH level of 4.5 to 7.5. Duckweeds provide supplements for other animals and even a rich source of vitamin A and B for humans. Next slide, please.
The Prunus avium, commonly known as the ornamental cherry tree, has colors light pink, white, and yellow. This is a type of prune tree that's native to Japan. The best sun exposure level for the plant is full sun, and its preferred soil is well drained with a pH of 6.5 to 7. Other than being beautiful, this cherry tree also symbolizes spring and even renewal and hope. Next slide, please. The Chinese fountain grass, or called Panaceum alopecaroides, has colors from pink to tan. This is a perennial grass that's native to Asia and Australia. It grows in full sun exposure and prefers moist and well-drained soil that has a pH of 3 to 10. Also, with the seed of the Chinese fountain grass, you can make flour for emergency food. Next slide, please. The blue-eyed grass, or in scientific name, Cinereach, actually, you know what, I'm just gonna say it, is a type of flowering perennial native to North America and consists of colors blue to violet. This grass is usually 20 inches tall and grows best in full sun exposure with moist soil that has a pH of 6 to 6.5. This beautiful grass's roots are often used for tea and even treating diarrhea. Next slide, please. The mondo grass is a type of evergreen perennial that's native to Southeast Asia, has a height of less than a foot, and consists of a light green color in full sun exposure. Mondo grass needs full to partial sun exposure and a well-draining soil type with a pH level of 5 to 6.5 to thrive. Like the wisteria, they are low maintenance and can grow well under unfertile soil. Next slide, please.
Creeping juniper, or Juniperus horizontalis, is a low maintenance shrub that is commonly used as ground cover in gardens and can grow up to 10 feet high. Ground cover is needed in East Asian themed gardens to provide contrast with the colorful flora, which is what it does here. Like most low-growing plants that prefer full sun exposure, the creeping juniper is low maintenance, meaning that it should not be watered often. You can find the creeping juniper everywhere. It is a native plant to the US that grows from slopes to riverbanks. Next slide, please. This Japanese maple, also known as Acer palamiton, is native to Korea and Japan and can be found in colors red, green, and orange. This 20 to 35 feet tall plant thrives in full sun exposure to partial shade and prefers well-drained, organically rich, and acidic soil with a pH level of 5.5 to 6.5. You will have to add ground sulfur to the soil to increase acidity levels. Also, the leaves of Japanese maple plant can become a treat when fried with sugar batter. Next slide, please. The bush monkey flower, called Mimulus aurantiacus, is a flowering perennial plant that is less than 5 feet tall. This plant is native to North America and can be found in orange, pink, yellow, and red colors. The bush monkey flower does best in full sun exposure with moist soil with a pH level of 5 to 8. Additionally, this plant can attract many types of insects like butterflies, be put into salads, and made into tea. Next slide, please. The mountain violet is a type of perennial herb that is native to North America. This plant is 1.1 feet tall and consists of colors purple and yellow. Mountain violet does best under full sun exposure with silt or sandy soil with a pH level of 6 to 6.5. Furthermore, this plant can host multiple different butterfly and moth species like Northwest fritillary. Next slide, please. In this drawing, the wisterias are, next slide. In this drawing, the wisterias are planted on the exterior of the two outer rock paths, and the azaleas are planted on the opposite side of the wisterias. Next to the azaleas are the creeping junipers, the mondo grass, and the blue-eyed grass. The plants on two sides of the middle path are the ornamental cherry trees. Near the pond, there are Japanese maple, bush monkey flower, and mountain violets, and inside the pond, there are water lilies and duckweeds. Furthermore, surrounding the rectangular path near the pond are giant cane bamboos. Lastly, there are fences surrounding the whole garden and sprinklers located in different parts of the garden. Next slide. After researching and learning more about the different plants, we discovered more about the different soils and their pH levels. We also learned about diverse landscapes with an extensive amount of native, non-native, and even invasive plant species. After doing this project, we found out that taking care of a garden is not as easy as we thought it would be. After all the time we spent on this project, we all improved on finding more valuable and safe information to use. Next slide. Thank you for watching.
Thank you. And I'm going to stop the share. So Catholic girls, are you ready?
Yes, we're ready.
You're going to allow some Q&A, right, Andy?
Oh, I guess both because they belong to one group. So I guess we can Q&A together. Do you think so?
I guess, yeah, I have a quick question because I think they have different topics. I think it's better to ask them separately. Is that okay, Andy?
Oh, yeah, sure. Okay, let's just have 5 minutes Q&A. Okay, yeah.
Okay, yeah, I'm curious what the coach instruction is, but from the topic, it's a California native plants, but it seems that a lot of plants you just introduced, they are not originated from Southern California. So can you kind of explain how you select these plants? Like what's the criteria versus, is that considered native?
Can we have the students answer the question, please?
Well, some plants are native, like wisteria is actually native to North America, and mountain violet. But since it's like a Japanese or an Asian garden, I feel like we should also consider some non-native plants to go with it. And yeah, does that answer your question or?
Yes, thanks.
Okay.
Okay, do
any other questions from any other judges?
Yes, please.
So this is a coaching. Hey, I have a question. So you have a lot of plants selected, as you say, your criteria can be select some native plants and the non-native plants. So what is your design basis? Like, how do you know those plants can work together in this garden? And what is the basis for choosing those plants over other plants? And what is the design criteria for how many plants are you choosing, and what is your restriction factors?
So one of our other goals for our garden is also a sort of colorful aesthetic, which is why a lot of the plants we chose. So they're also low maintenance, meaning little to no watering throughout the week, but they're also very colorful. There's a lot of reds, whites, pinks, which contrast well with the greens as well. Yeah, in general, our goal is just low maintenance plants that can be watered in frequently.
Also for the pH levels of the ground, it had to match the pH levels of what the plants can do best in. That's also how we chose some of our plants and made sure they would thrive in our garden.
And I also felt because the Emily's backyard is like a full sun exposure backyard, so all the plants are preferred to in the full sun exposure environment.
Okay, our Q&A. So let's invite Kathleen Groves to presenting. So Kathleen.
All right, we'll have Dory share her screen.
Okay, please share.
All right, hello everyone. My name is Caitlin. I'm part of the water conservation group. The other members will be providing. Dory, would you like to introduce yourself?
Yeah, hi, my name is Dory. I'm part of the landscape design group.
Hi there, my name is Daniel Wu, and I will be the first speaker for today. All right. What the? All right, sorry about the disturbance, folks. Anywho, property description. Team 1 chose this backyard with a steep slope and a large area for planting a multitude of plants. Due to the angle of several trees in the house, this area has the perfect amount of shade, partial shade, and sun throughout the day, as well as 2 sprinklers for abundant watering in the splash zone where the water stream ends, providing a different level of moisture for a variation of Californian vegetation based on where they are planted. This backyard also has a paved rock road, which can support 3 to 5 beehives placed at the right position. Next slide, please. Now, landscape goals. You might be wondering why I mentioned beehives in the previous descriptor. Well, you see, the goal is to conserve the native bee and honeybee population by allowing wild bees to feed off of the garden, and the bees we keep in the 3 to 5 bee houses to feed and continually spread across the environment. As you probably know, due to industrialization, habitat loss, stressful transport, and harmful mites, bee colonies have been dwindling for decades now. Even the bumblebee has been continually declining as pesticide use and habitat loss drove one of America, Asia, and Africa's most important pollinators down the path to chaos. Honeybees are also suffering. Truck transport and poor living conditions allow bee colonies to collapse due to stress or to mites and diseases. As smoothly carved wood bee houses prohibit the full use of their antibiotic saliva, which they use to keep their hive clean. That's why I'm using scrap wood to build bee houses, and why we want to help. By filling the backyard with a huge amount of bee-friendly flowers and setting carpenter, honey, and mason bee houses around the paved rock road, we can make a major difference in terms of supporting our native bee population and feeding all native bee predators as well, allowing all of LA's fauna to thrive. P.S. We are not responsible if any of our bees sting or bite you in defense of their colony. Also, I'm sorry for the stuttering. It is very hard to read out of the light of a window. Next slide, please. Microclimates. As you can see, due to the position of the house and the tree, along with the rising and setting of the sun, this allows for a full shade area and a partial shade area. The direction of the path also creates water runoff, which creates an erosion area that you can easily fix with some spread-rooted vegetation later in the design. Lastly, for unknown reasons, this side of the garden has always been extremely dry, despite being watered the same amount as the other areas, leaving this place a dry area for other drought-hardy plants to inhabit. And the other areas are all full sun. Yep, LA is a sunny place. All right, now sending it off to my first plant presenter, Dory. Yay, cheering, claps, because no one else will cheer or clap.
Okay, thank you, Daniel. Now I will be introducing the first 4 California native plants that will benefit the bee population in different beneficial ways. Starting with the common yarrow, it is a California native plant that will be located in the erosion/dry area that includes full sun/partial shade, along with little water in the backyard. Its drought-resistant nature and extensive root system will allow it to capture and stabilize soil while requiring little or no water. Having common yarrow in our yard will attract many pollinators, primarily bees, which will fly from one yarrow to the next, taking pollen as they go. The next California native plant is Echinacea. This flower belongs in the full sun, little water area due to its ability to thrive in hot weather and be drought resistant at the same time. It can benefit bees by providing lots of nectar and pollen during the season in which they are most active. A fun fact about this native plant is that it was once used as a herb by Native Americans to treat a variety of minor illnesses. Moving on to the next California native plants, we have the California aster, which belongs in the full sun, partial shade, and little water area. Just like Echinacea and other California native plants, this plant is drought resistant, and what's special about it is that it can thrive in both full shade areas and partial shade areas. California asters are known for blooming from late summer through fall, therefore being able to provide a critical pollen/nectar source for bees. A fun fact about this plant is that not only do they attract bees, but California asters are irresistible to butterflies as well. Next, we have the California native plant Lily of the Valley, which belongs in the partial shade, lots of water area. This plant can thrive in both partial shade and full sun, and their roots enjoy moisture, which is why they're located in plenty of water area. This flower emits a strong sweet scent while it blooms in May that will inevitably attract bees, who are the main pollinators for this plant. With it being a classic spring flower, Lily of the Valley is the official flower for the month of May. Next, let's welcome our next speaker, Melissa, who will be introducing the other California native plants.
Thank you, Dory. I'm Melissa, and I will be introducing the next 4 plants that have a variety of benefits for bees. First is the common foxglove. The common foxglove is highly tolerant of drought, like many other previously mentioned plants, and is able to thrive in full sun, partial shade, and full shade. It's also naturalized throughout all of North America. The color and nectar of the flower attracts bumblebees, and its tubular shape gives bumblebees easy access to the nectar. Its name refers to its glove-like shape that seems to fit the paws of foxes. Next slide, please. The next plant is the beard tongue, also known as the penstemon. The beard tongues can thrive in areas with partial shade to full sun because having an adequate amount of sunlight keeps the plant upright. It grows better when it is watered once a week, which makes it a perfect candidate for an area with adjustable sprinklers. Beard tongues provide tons of nectar and pollen for a variety of different bees, and it also comes in a variety of colors that will inevitably attract lots of pollinators, including purple, blue, red, orange, white, pink, and yellow. Next slide, please. The third plant I'll be introducing is the Western redbud. The Western redbud grows best in areas with full sun because of its ability to produce more flowers in full sun. It is also drought tolerant and grows easily in well-drained soils. The Western redbud shrub attracts both honeybees and carpenter bees. When it is grown in sunny conditions, the flower produces more nectar, which is another benefit for bees. Next slide. The last plant is California coffee berries. The California coffee berry belongs in this category because it has adapted to local weather conditions in California. Therefore, it requires little or no extra waterings to grow. It will also thrive in shaded areas as well. The young stems brighten the plant with their reddish color. The spring blooming flowers are greenish and quite small, but they attract many pollinating insects with their bountiful amounts of nectar that they produce, despite their tiny flowers. The berries of California coffee berries are sweet and edible. Thank you. Now to Caitlin, who will be presenting the next slides.
Hello everyone, so I'll be covering the Biden flowers. So Biden flowers are easy care and long blooming plants that are easily recognized in garden beds. These flowers usually bloom in yellow or orange, so they're very vibrant colors, and they usually populate in warmer temperatures. So Biden flowers typically can grow in partial sun conditions, but for the best type of bloom, full sun is definitely recommended. Also, regarding the amount of water, Biden flowers are considered fairly drought resistant. So this means that little water is needed, except for special circumstances. So Biden flowers thrive in full sun and only needs extra watering when the temperature is extremely high. So they're native in the southern half of the United States, and these tough little weeds are perfect for a garden. Like the Western redbud, it produces more flowers in full sun, which benefits both butterflies and bees. Its pollen and honey-scented flowers attract many insects. Next slide, please. The finished garden design incorporated all of the following plants that we talked about, such as the Western redbuds in the full sun, common foxglove in the shade, California coffee berries in the partial shade, and so on. As you can see, all of them have a specific place in the garden, so that will help with thousands of bees as generations go on. Next slide. For our summary slide, the summary of this entire slideshow includes examples of the plants that can help wild feed off of. The main goal was to help conserve the native bee population by creating bee-friendly gardens that help with the continuous spread of bees in our environment. Plus, due to all the drought-resistant plants incorporated in this area, this flower garden will also support the cause of water conservation as a perk. Thank you. So the next slide will be covered by Daniel Wu.
There are no more slides. Thank you for listening. But before that, please give the previous performers a round of applause. Again, silence.
Nope.
Wow. No more applause. I worked so hard on this.
Okay.
And who?
Okay.
Hey, who? Thank you for
Doris.
listening. Yeah. Any questions?
Can you please stop to share your screen? Okay, now it's time for the second team, Q&A 5 minutes. So let's have the 5 judges. If you have any question, it's time.
Yeah, I have a question. By the way, yeah, thanks for a lot of lovely pictures on plants and flowers. You mentioned about you have 2 adjustable sprinkler. Is that right? So is the design consider, certain plants might need a little bit more water and versus others, and also how frequent, you need to water these plants?
Yes, we did our research and the design. Well, you see, here's the special thing about our sprinklers. For some reason, the water stream goes in rows, so anywhere under the water stream doesn't get watered during the process. So we incorporated plants that would moisten roots or any kind of moisture in their daily processes, really. And then, we just put them in the sprinkler section. Does that answer your question? Or?
Yes, thanks.
Mm-hmm.
Okay, any other judges want to ask a question?
Yeah, I thought it was really interesting. So one of the objectives is bee conservation in addition to water conservation, right? And so when you design the project, I was just wondering, how many people would actually like to have beehives in their backyard? And then would that be a feasible goal when you design this project? And just want to get your take on that.
And team members can answer the question.
Can I just say the beehive's optional? The main goal is to attract the bees and give them some food, which is the flowers. But our team is, they love nature. So if they can help nature however they can, they've added beehives.
But the other thing is that we let them choose their own property. So this is actually his property, like one of the team members' property. So he wants that in his garden. So he's the client. I don't know if it's power affecting their their ability to actually connect and answer the question or not. I don't know why there's sudden silence. Sorry about that.
This is why I encourage all the kids, when your team is presenting, turn on your camera, at least you can do the eye contact and see if anyone wants to talk. Because right now you cannot see your team member's face. You don't know if he or she wants to speak. Okay. I think we're hit the time limit already. Should we move on, Andy?
Yeah, yes, of course. Okay, let's move to the next team. So next team will be the Surface Water Management Group. And the team member will be Alexandra Mong, Eric Wang, and Eric Toy, and Justin Ford. So please, ready? When you're ready, please share your screen.
Hi, can everyone see my screen?
Yes, we can.
Okay, so we'll start now. Let me present. Okay, so hi everyone, we are the Surface Water Management team. Our team members consist of Alex May, Eric Wang, Eric Toy, and Justin Ho. Today we will be going over our surface water management presentation. Our agenda would be first, introduction to surface water management. Second, challenges surface water management encounters. And finally, we will be summarizing our main points into a conclusion. Okay, so let's welcome Justin Ho to give us an introduction to surface water management.
Yeah, so thanks, Alex. Yeah, so for introduction to surface water management, yeah, so next slide. Yeah, so as you can see on this diagram, you know, the world is filled with water. So 97% of our water actually comes from oceans, and there's only you know, 3% fresh water in the world. As you can see, ice caps, glaciers, groundwater, and surface water, which is lakes, swamps, and rivers, are the subject we're going to be going over today. So next slide, please. Yeah. Okay. So yeah, there's a lot of water pollutants, as you can see in these pictures. You know, the first group actually mentioned about PFAS. Yeah, so that actually, you know, links to our presentation too, as, you know, water pollutants are contaminating watersheds, oceans, rivers, lakes. So yeah, there's a variety of stuff here that demonstrates, you know, pollution such as pesticides, plastics, glass, you know, other stuff, you know, metals, construction sites, and biohazards, which are being dumped in our water sources. So that's a very big issue that we want to tackle today. So next slide, please. Okay, so what is a watershed? A watershed is basically a land area that channels rainfall and snowmelt to creeks, streams, and rivers, and eventually outflows to points such as reservoirs, bays, and the ocean. So, you know, watersheds provide us with water. And, you know, in California, since it's so dry, we have, you know, aquifers, you know, channels, and, you know, just to give up some point. So yeah, so we channel water from other, you know, states too, such as, you know, Colorado, Nevada. You know, that water travels a far distance to get here, to supply Los Angeles with water. So next slide, please. Yeah, so why do we need healthy watersheds? Well, I think, you know, the answer is pretty obvious, especially for California, because, you know, living in a desert condition, we need clean drinking water. And, you know, we also need that water for recreation, for, you know, our city to thrive and grow, because without water And without clean water, our population will suffer, not just health-wise, but economically and yeah. So a lot of different impacts will be made if we don't have clean water. So next slide, please. Yeah, so stormwater. Basically, stormwater is water following a rain or snowstorm that does not infiltrate the surface of the ground, meaning that it's just basically water which flows down the drain and is not used wisely. So stormwater itself is very clean because obviously it goes through the process of cleaning the clouds, and then evaporation removes dust and dirt, and etc. But it's very sad because a lot of water gets wasted in the drain, and it could be used for good stuff. So yeah. So in the next slides, our team's going to talk about solutions we learned to use the stormwater efficiently. Yeah. So yeah, next slide.
Okay, hi everyone. I'll be going over the first challenge that surface water management encounters. So going over the water quality issue. The main water quality issue we experienced so far is water pollution. Based on our context, a pollutant can be defined as a substance or energy introduced into the environment that has undesired effects or adversely affects the usefulness of the resource. So water pollution could be characterized into two main types, organic pollution and chemical pollution. Organic pollution is caused by deleterious microorganisms such as bacteria and viruses that are generated by excrement, animal and vegetable waste. And the chemical pollution, just like its literal meaning, is the chemical pollution that is caused by pesticides, waste chemicals, phosphate, heavy metals, acids, etc. So here are some of the examples of water pollutants. As you can see, there are nutrients, pathogens, oil/grease, pesticides, sediments, and trash. So here are some shocking statistics regarding water pollution. So I'll just be going over a few. So as you can see from the third stat, 80% of the world's wastewater is released back into the environment, which means the wastewater is not as clean as before. So it's going to pollute the environment, which is bad for organisms and humans and plants. And as you can see from stats number 6, 100,000 marine mammals die annually as a result of plastic pollution. So this shows us how dangerous plastic and water pollution can be for marine mammals, and not just marine mammals, but all marine animals and organisms that live in the ocean. And as you can see from stat number 1, every day 2 million tons of sewage, industrial and agricultural waste is released into water around the world. This is equivalent to the weight of 6.8 billion people. So this is very shocking as how humans are treating our waters very dangerously and bad for our environment and our overall future. So I will be going over some solutions. So as you can see from the top row, which is solution 1, 3, and 5. So some solutions for water pollution would be wastewater treatment, stormwater management, and watershed management. These three managements can help purify water when it goes and released back to the nature, causing fewer animals, humans, and plants to drink or consume polluted water. Now let's welcome Eric Wong to present challenge number 2.
Challenge number 2, water resource issues. The first issue is water scarcity or shortages of clean water. The second is the world population growing, leading to the demand of water increasing. And the third issue is water pollution leading to less clean water. Next slide. Here are some solutions to water pollution challenges.
I think we lost the voice.
Here are some solutions to water pollution challenges. Here are some case studies on surface water management. The OC Public Work Glassell Campus Low Impact Development. The project was designed to achieve 100% stormwater treatment and 85% retention for the design, storm by constructing a series of LID best management practices. Big Canyon Nature Park. The project constructs a low flow diversion and stormwater bioretention treatment wetland to significantly improve water quality in the Big Canyon Wash. The 6-acre project will also remove all invasive plant species and restore the watershed with a native plant palette. I will now pass it on to Eric Toy to present conclusions.
In conclusion, surface water management is vital to the well-being of humans and nature. Both water quality and water resources are important. Stormwater management is important but also challenging. It is best to manage water quality and water resources on a watershed scale. Next slide, please. This is our field trip video that we wanted to share. This video is a collection of the valuable insights we gained from our field trip. We have 4 field trips with the following themes: stormwater management, watershed management, habitat restoration, and water resource management. The contents we presented are based on what we have learned from the field trips and coaches.
Can everyone see the video?
Try to find some orange juice because we're orange fans.
Or bay. So that's really low right now, right? Then get absorbed into the ground rather than directly out.
The very beginning of this San Andreas River into the ground, so the water will go into equal pressure. So this salt water can't come this direction because it's equal. Online, the water column would drop 13 feet a day. 3-year journey to get here, but we got it figured out.
So thank you everyone for listening. And that's it for our presentation.
Thank you. Please stop to share. Okay, now it's time for 5 minutes for the judges.
So, what is the most impressive thing you learned from this summer camp and the field trip? Anybody?
Yeah.
So for the most important thing we learned from our field trip is probably how to conserve and filtrate the water for future uses. For example, we learned how to filter water based on our field trips and some of the Zoom meetings and videos and readings assigned to us. So we learned like how to do stormwater management, and we went to a basin and how like the nature park, our second field trip. We learned how to purify water and how those water can sustain a whole ecosystem full of organisms in there.
Okay, I guess Elaine has a question.
Yeah, I thought it was a pretty comprehensive overview of the whole surface water management practices. I just wanted to know a little bit more about that. After your research and field trips, what do you think the most urgent issue is in Southern California right now? And based on what you learned, what would be the best solution to address that issue?
Yeah, I guess I can sort of pitch in on this question. Basically, I think for those locations are mostly in OC or Orange County. I live in Los Angeles County, so obviously, I think obviously California has an issue with a drought, especially Southern California, yeah, and I think a lot of the water here is from the introduction slide I mentioned, like the surface water, the rainwater, which is being, wasted in the drain system or being mixed with the drain system, actually. So obviously, I think, from the field trips, especially, I think the first one, the biggest issue to tackle, I think, is basically just changing the sort of method we try to conserve water and try to implement new technologies to sort of help us with that. From the field trip, Professor Peng, he basically educated us on, pavements to use rainwater to clean the pavements. Besides using like cleaning trucks, which, waste a lot of water. We also learned about how to, basically make a rain box to collect water and to filter it to plants. And then, probably remove like some dirt from it to then go into the sewer system. So yeah, I think just mainly an issue we want to tackle on, or the biggest issue actually, is just, how we get that funding and how we prioritize, some of the goals we have to, implement, especially for water, because it's such a hot topic right now in California. I know a lot of people have different ideas, but I think we should probably start with the basics, such as, how we, change like a traditional way, like probably just, collecting rainwater, to how we, implement new technologies, such as, getting, watering trees at the same time and cleaning pavements, and then, recycling that water. So yeah, I think that's a main thing we want. So yeah, I hope that answers your question, because we learned a lot of different stuff. So there's a lot to say. If I just cut it down into like a short, 3-minute response, I guess.
Yep, you did answer my question. Thank you.
Thank you, Justin. So I guess we should move on. Okay, next we're gonna welcome the group of microbiology and water treatment group. So we welcome the team member, Mark Hort, Daniel Chu, and Gary Xu. So when you're ready, please start to share your screen.
Unfortunately, Daniel won't be joining us for this presentation.
Okay, you can continue.
Okay, so the necessity for more efficient wastewater treatment systems to support California is directly linked with the drought crisis and escalation in water withdrawal countrywide. As shown by the US Drought Monitor, almost all of California is in either D3, extreme drought, or D4, exceptional drought.
As an effect of extreme droughts, hydropower energy has significantly became less viable. This can be seen in the Hoover Dam as water levels rapidly drop, risking roughly 75,000 people's worth of electrical energy.
So all wastewater treatment plants involve microalgae are built on the concept of removing excessive nitrogen phosphorus from water while growing algae as a byproduct. And you can see here that the microalgae's consumption of nitrogen and phosphorus effectively cleans the wastewater of discharge from human feces, food, and soaps. And this also allows for the growth of the microalgae, which can be used as a biofuel with the same energy potential as coal. Additionally, microalgae treatment is a lot more cost-effective than traditionally activated sludge treatment methods. They cost about $300,000 annually, whereas the latter is twice as costly, with an annual rate of $600,000.
The microalgae wastewater treatment plant involves a cycle with a heterotrophic bacteria. Wastewater containing nitrogen and phosphorus is inputted into the circle, which fuels microalgae's growth and production of oxygen. The bacteria within the system consumes oxygen and additional organic matter to produce carbon dioxide. This carbon dioxide then gets absorbed by the microalgae to finish the cycle. Once wastewater depletes the nitrogen and phosphorus, a separation process collects all of the microalgae. Since the microalgae is solely powered by sunlight, there is no excessive use of electricity. Instead, the treatment plant produces biofuel with reduced greenhouse gas emissions.
Different variations of the microalgae systems include the raceway pond, tubular photobioreactor, vertical photobioreactor, and flat plate bioreactor. And these designs all go with their own flaws and limitations. So starting with the raceway pond design, it is primarily restricted because of its open lid design. So most of these limitations are geographic. It cannot be built in locations with more than 1,000 millimeters of annual rainfall or constructed in a way that would cause more than 2% land slippage. The open design of the raceway pond also makes it prone to bacterial and viral contaminations. In addition, factors such as pH, oxygen, and carbon dioxide must be carefully maintained in balance. Then the other major problem with this design is that it doesn't produce very much microalgae in general. The tubular photobioreactor's dependency on sunlight makes it susceptible to seasonal and weather changes. Top of that, an efficient cooling system must also be installed to keep the microalgae alive.
The vertical photobioreactors are unable to be used in large-scale settings due to limitations of scaling the system up. This design is much more ideal for indoor testing and sampling. Similar to the tubular system, flat plates photobioreactors rely on extensive surface areas for coverage for efficiency. It is also vulnerable to varying weathers and temperatures. Additionally, the design of the system may lead to overheating. However, differing from the tubular design, flat plate photobioreactors are much more cost efficient.
Yeah, that's it. Our presentation's a bit short.
Thank you. So now it's time for 5 minutes. Judge's question.
Yes. You talk about the limitation of this different, treatment system. So have you guys looked into, any improvement that can be made, or what's kind of the best of those? Which will be most effective? And if any improvement can be made on the current systems?
On the current microalgae systems?
Yeah.
We did not put that much research into that department.
Okay, how about comparison of the current system? Do you have idea which might be most like practical?
Yeah, we compared it to the traditional activated sludge treatment method, and there are a lot of benefits. Like mainly, it's more cost effective, and also you get this microalgae byproduct that can be used as clean energy.
For now, though, I do believe the flat plate photobioreactors are, better since it's more cost effective and it doesn't have as much limitations as the other one.
Okay, thanks.
Can I ask you guys, how do you think your teammates, how do you work in a team environment? How do you describe your team interaction?
It was a bit bumpy because it was hard to get everyone on at the same time. Our other guy didn't really participate much, but yeah, we just worked on it together, I guess.
How do you think, what kind of role did your coach play in your whole learning process?
Definitely the coaches made things a lot easier to understand. I went back to the Zoom recordings multiple times to get the grasp of the concepts.
Cool, thank you.
Any question from the other judges? Okay, if not, we're going to move forward. So we'll welcome.
Elaine, are you going to ask a question or?
Yeah, maybe just a quick one. So I think this this project is pretty pertinent for the previous presentation, right? For the wastewater treatment as well. So do you think there's a synergy that you see for your project to be applied in the wastewater treatment that was presented by the previous team?
I think they have their own benefits and they could work along each other, but maybe not combined. I'm not so sure.
Thank you.
Okay, so right now we welcome our last group. Is the methane in groundwater group. So we'll welcome the team member Howard Ye, Karen Miao, Angela Lin, and Tao Shen, and Erica Song, and Zachary Ge. So I'm sorry, may I ask you a question about Dr. YR? So is you separate two groups or you can be together about Wednesday Li and Tony Wang and Lily and Shan? Yeah.
This is the same group. They just are writing two sections separately.
Okay. Got it. Okay, so welcome all of them. Okay, so
I think you missed that 4 members, right? You want to go through one more time?
Okay, yeah. So I'm going to welcome the members of the Tao Shen, Eric Song, Zachary Ge, and Howard Ye, and Carolyn Miao, and Angela Lin, and Wednesday Li, and Tony Wang, and Lili, and Shang Ye.
Thank you. So before I start, I just want to say this project is from real life problem. Okay, 2018, Ventura County detected methane in their drinking water aquifer in groundwater. So since then, they try to figure out where the methane coming from. Is it coming from bacteria degradation or coming from the nearby drilling oil and gas field? So this is a real problem. So our project gave to the team, and they learn a little bit about everything. So we prepared a video clips. So enjoy.
Thank you. And when you're ready, please share your screen.
Hello everyone, my name is Wenxi Li.
I am Karina.
Hello, my name is Angela.
Hi, my name is Jay Shen.
Hello, my name is Eric Song.
Hi, my name is Zachary.
Hello, I'm Howard.
Hi, my name is Tony.
Hi, my name is Sean.
Hi, my name is Lee.
And we present you our methane in groundwater final project. Enjoy!
I made a model of a methane molecule. Methane is made up of 4 hydrogen atoms and 1 carbon atom.
I will be talking about my drawing of the groundwater profile. As you can see, I've created a basic drawing with the components of groundwater. And you can see that I've included the unconfined water, the aquifer, the aquitard, also called confined layer, and the bedrock. In it, you can also see that the water table and the water source is mentioned, which is the river. And the water table is basically where the unconfined water started.
Methane is an organic chemical compound with the chemical formula CH4. Its molecule is nonpolar and therefore it is a gas at room temperature. It belongs to the family of compounds called the alkanes, which typically consist of carbon and hydrogen atoms arranged in a tree structure. This family of chemicals is known for its flammability.
Methane is a colorless, odorless, flammable gas which is the main constituent of natural gas. It is the simplest member of the alkaline series of hydrocarbons. Natural gas, which primarily consists of methane, is the cleanest burning fossil fuel. However, methane that is released into the atmosphere before it is burned is harmful to the environment. Because it is able to trap heat in the atmosphere, methane contributes to global warming.
Methane, which is relatively abundant on Earth, is widely used for its flammability. It is the primary constituent of natural gas, a common fuel in homes, automobiles, and more. Methane is a major greenhouse gas responsible for 20% of radiative forcing or heat transfer capacity. In the atmosphere, methane is emitted from various sources, including decomposition, animals, industrial waste, and more. Methane is not toxic, however can be asphyxiant if volume is substantial enough to lower oxygen concentrations below 16%.
These are the methane properties. Molecular mass is 16.043 grams. Melting point is negative 182.45 Celsius. Boiling point is negative 161.5 Celsius. Flash point is negative 188. And the solubility water is 22.7 milligrams. And then the color of methane is colorless and the odor is odorless.
Methane can get into drinking water in two ways. First, methane is a natural product of subsurface bacteria. Secondly, methane can leak from deep underground storage fields. And after methane dissolves into groundwater, it can then enter the drinking water supply to houses.
Since methane itself is not considered toxic, there is no existing drinking water standard for methane. However, according to the US Department of Interior, if the concentration of dissolved methane gets greater than 28 milligrams per liter, then flammable methane could be released.
Methane is not explosive when it is in the groundwater, but after the dissolved methane reaches the air and escapes from the water, it can then cause a danger of fire or explosion in a confined area. If methane is released indoors, it can also lower the level of oxygen and eventually making breathing difficult.
Though there have been occasions in Pennsylvania when house camps or wells exploding due to elevated concentration of methane in water. Therefore, it is very important to test methane level in well water once there is extensive bubbling in the water. Later.
There, oh, that's it. Yes, that's it. That's what we've got, all right. Oh no. Don't lose that, no.
There's no methane.
Pretty good, huh?
Yes, very creative. So
that was Tony Wang. That was our director for the video. The video was edited by Wency Lee, and she put together. So just want to add one more thing. We did write a report. We're not able to present the whole report, but the report being submitted, hopefully coach can read it, where the team members start learning how to calculate molecular weight, for example. So that's in the report.
thank you, Dr. YR. So now it's time for the question. So let's welcome CY, Judge CY.
Sure. Yeah. So yeah, very nice video, comprehensive. I'm curious about the cases that your coach mentioned at the beginning. What's the outcome, and like what you guys learn from, that kind of incident?
And we have the students answer the question.
Okay, I'll answer. So basically what I think Mr. YR was referring to at the start was the amount of methane at the Ventura County. And what we learned from it was actually that methane is actually more abundant than you think it is in the groundwaters, and it's also not a really good thing to have it in groundwater, which is basically the main lead of drinking water or like irrigation for crops.
And yeah, I would like to add on. So like Dr. YR mentioned, so I think the county was curious like where the methane in drinking water came from and like how can it affect our health. So after our research, we found that I think we mentioned it in the video that methane can get into our drinking water in two ways, and then there's really no health problem caused by methane because it's not really toxic, and the risk of high concentration of methane is explosion if it reaches a heat source. And hope that answers your question.
Yeah, thanks.
Okay, let's welcome Judge Elaine.
Yeah, so just wanted to follow up on what Wency that you just answered. So if there's no adverse health effects, and then the main problem is its inflammability. So do you believe that there should be any regulation after your research? And what is the basis for this regulation?
Yes, like we mentioned in the video, so levels of dissolved methane, if it gets greater than 28 milligrams per liter, then it can release flammable amounts. So, and before it releases the flammable amount, I think when methane gets like the high, when methane hits like a elevated concentration, it will actually produce bubbling in the water. So yeah, if there's like an extensive bubbling, then we should test for methane levels to see if it's like near 28 milligrams per liter. And if it is, then I think it's very important to like leave your house immediately, because then there's a potential risk of explosion.
Also, to add on to Wency's response, so actually in the video it mentioned that methane could actually cause, like methane actually reduces the amount of oxygen, meaning if you drink water with with too much methane, you actually get headaches, your heart rate increases, and you also get numbness and possibly be unconscious from drinking too much water with methane in it.
Any question from the judges?
Professor Xu, looks like you have a question.
Yeah, I think Dr. Shen already asked my question. So my question was what the policy implications of your findings? So what could be done? Yeah.
Xiongzhang is trying to ask a question, but it seems like we cannot hear him.
It's okay. Let's answer the Xu Lei's question first.
I think it kind of repeats what Elaine's question was asking for, and I believe the team member already addressed that.
Okay, yeah. I saw the video, which is very creative. So the question is related to the last scene on the video. So if you do see, if we do find a lot of methane in the water, what's the water taste like? How can you tell there's no methane after you drink the water?
So methane itself is actually colorless and odorless. So I guess you can't really tell if there's like methane in your drinking water, and it doesn't really cause any health problems. So I guess you can drink certain amount of methane, and you won't even know. Yeah.
Okay, that's good answer.
Did you guys study into the solubility of methane in water?
Yeah, it's pretty low. It's very low, actually. It's like 100 times less than salt.
Also, there isn't really a good way to tell if there's methane in water, except you could actually use, there's also carbon monoxide detectors where you could actually test it, but you need to have like one of those testers. But also, if you had like a match, you could also test it, because you could hold a water bottle upside down for a while, and then when you open the cap and then you put the match over the water, it won't actually explode, but if there's a little flame, then it means there's a little bit of methane in your water.
Do you guys think with the solubility of methane in water so low, would it actually cause any flame if you put let's see, a flare source nearby? Any thought into that?
Because it's so low, you usually don't really need to worry about it. But the point is that there might be certain times where the methane levels might spike, so you need to be aware of that. So normally it's not that big of a deal, and and for most groundwater, the tiny amount of methane is not going to have any. You're not going to notice it, and it's not going to cause any. It's not going to cause any bad things to happen, but sometimes it might spike, and then you need to evacuate your house, because if you light your stove, then your house might explode.
So team members, do you remember in the class we're talking about the solubility compared with other things? Anybody still remember?
Okay, I guess our Q&A session will be finished. So all of our teams will be already finished their presentation. So we're gonna send our judges to a breakout room to doing the final evaluation. So please hang in there and waiting our response. and during this process, we are inviting our guest speaker to have a very special speech for everybody. So please hang in there. Let me send our judges to the breakout room.
Let me ask, I think I see most of our judges is Guojing Liu. Are you on? Can you, because we need to tell which one is you so that we can send you to the room. Guojing Liu, can you change your name maybe so that
maybe you can turn on your camera so I can see you. Yeah. Okay. So for this period, we'll welcome our special guest is from the Percival Education. Percival is our summer campus sponsor, and we'll welcome the Kelly. And Kelly Chen is one of the education consultant of working for the Percival Education, and she's graduated from Columbia University, and she's got her education master degree, and she's majored in teaching, researching, and she's got a very passion in high students' life and coaching and leadership development. So today she's gonna bring some very insights for how to help the students to stand out in their college application. So welcome, Kelly. Yeah, it's your turn. Yeah.
Hi, everyone. Thank you, Andy. Can you guys see my screen?
Yes.
Yeah. Okay. Yeah. So I'm so honored and happy to see so many great advisors and also all of the great students. You share a lot of interesting, insightful about what you learn from the this environmental summer camp. So really congratulations, everyone. As a teacher at Perceiver, we are really happy to help students to build a confidence through doing a real projects. So for example, like AEC Foundation Service projects, we have a different kind of clubs. So maybe you are very familiar with the environmental, we call it RUP. But we also have other, options like special education, where people are interested in helping people to, write in English. And then we also donate a mask during the COVID situation. We help the community to build a better, understanding with each other. So we strongly encourage you not only just join a, short class, but also really deeply involved in the long-term service projects and then learning the research topics, more with more commitment and more energy. Okay. And then I think most of you, I have seen you in the Robert's class. Previously, we had one called service leadership. I guess most of you may be familiar with the 4 stages. So it's really great to have a start. You do some research, no matter it's water pollution or air pollution, you find something you care about, right? You do some research. You went to see the real situation and you look up more information online or more from the article. And then you start to take action. For example, you would like to join some clubs, right? And then you find some like-minded people or professional experts to learn and grow together. And then the next step will be influence others. We hope you can contribute what you learned and then promote the idea to more people. So more people know, oh, we should more care about the ocean, care about the water, what we use, or even publish your research, even promote on the website. And then the last stage will be reflection and improvement. So it's ongoing project. So your learning just started. We hope to help you, guide you through the different stages and then see you grow and learn. Okay. So Perceiver is a college application mentoring institution. So we was founded in Los Angeles in 2014, and you can see a lot of people here. They are scientists, they are educational experts, and in different industries and in different categories, different subjects. And we are a team led by the USC and UC Berkeley and UCLA, the previous admissions officers. So they know how to help the students grow and learn with confidence with some methodologies. And later on, I will introduce the student's case with you. You can see the photo. This guy is the left side, the gentleman is Mr. Robert. I think most of you have seen him before. And the right side is Dr. Alex. So Dr. Alex is he was the previous USC admissions officer, and they worked together, created a methodology called the STEPS, STEPS. So each element stands for a concept. So S means scholarship, which including like everything related to academics, like your GPA, your SAT, your AP exams, and then your AP courses. T stands for talents, like your passion for music, sports, or even environment. And E stands for expression, like how you express yourself with critical thinking, and then you can have a better, written skills or oral presentation skills. And then for the P is stands for purpose. It includes your maturity, how you see the world, how much you know about yourself, and then what would you like to contribute to the world. Yeah. And last one is S for service. That is really interesting. We are talking about today, no matter it's environmental topics or something you resonate and you want to help other people in different kind of communities. All right, so I will play a short video as Robert talk about more deeply about the steps. Can you guys hear? Yes.
Most Chinese students overemphasize the bottom two. They spend way too much time, too much effort, too much emphasis on the bottom two. What happens is they get a good grade and good GPA and they get good SAT score, but they still can't get into the top universities because they don't have anything else to show for it. They only have two pieces of the entire application. So you need to balance. You need to have all of the good grades, but all of the other pieces together to make you a strong candidate. In your mind, how are you gonna balance all of these things?
Firstly, grade is the fundamental things. I try to study hard at school, do some sports, and practice my instrument. In the school band practice, I think it can practice my leadership, hopefully.
All right, so what we suggest is a very structured method to first understand what are all the pieces that are required, and then allocate time and priority to prepare for them. S is for scholastic aptitude. What that means, scholastic aptitude means academics. Universities will evaluate your transcript. We look at your GPA, we look at what classes you've taken, your ACT or SAT scores. T stands for talents and passions. T is for you to show the admissions officer what you're good at and what you care about. This one is Tiffany. She wants to be a doctor, so she's doing an internship at Stanford in the surgery. So the next step in the steps is E. You have to express your viewpoint with independent thinking, with critical thinking. You have to be able to express your emotions and opinions. How smart you are, nobody knows, because I can't read your mind. I can only judge you by what you say and how you say it. Okay, the next step is P for purpose and maturity. First, you have to know yourself. You have to know, what's my purpose in life? Why am I going to university? Why am I studying economics? College admissions officers expect you to be mature. They expect you to know what's my place in society, in the community. How can I contribute? How can I make a difference? Be done. And so service is all about actions. This is where you gotta really show that if you care about a cause, that you're going to dedicate some time, commit yourself to it. You're gonna do something meaningful and make a positive influence. AEC Foundation is a platform for students to do community service, and they can either join existing projects that's already there, or if there's another project that you care about, you can start your own, okay? So you look at yourself and says, this is where I am now. I have 2 years, or I have 1 year, or I have 3 years, whatever it is. How do I break up the time and plan out what I need to do and when and how much, how far, what kind of like results do I need before it's good enough, and then I try something else. Sometimes people can get from here to here by themselves. Other times they might need a coach, they might need a teacher. There are many, many components. It may be confusing, but they all need to work together. So we gotta clarify it for you. Over the next 7 days, we're gonna talk about all the components.
All right, so I hope you have a little better understanding about the holistic steps. It's really important to know that college application in the US is quite different from most countries, their systems. So they are looking at the holistic components instead of just looking at your scores, looking at your GPA. So they really want to see your qualities. If you are you are very curious, you have maturity, and then you are brave to take challenges. They want to see your persistence during your like service project or your competitions or your internship. So these are very important components that American college admissions that they are looking for. All right, now I would like to share to our fabulous students. One is Tiffany Zhang. She was the previous special education club president, and she's very interested in helping people through biology, through medical methods. So she actually joined our program, and then we helped her to apply the Stanford summer internship for the surgery. And also we also helped her to get into UCLA Medical School to learn some like gene editing, learn some medical industries. So she later on published some papers with the team. And then she also, helped the special education club to organize a huge seminar online last year. And the other one is Wellington. He was the previous RUP club president. He was very shy, and then he didn't know how to, express himself or speak up. But we encouraged him to take a leadership role, and he used his talents in computer science, like coding, and then he helped the club to build the website. And now he got into Caltech, majoring in computer science. So these are the interesting examples to let you know like how you can combine your passions and your talents into helping people, but also really help your growth and later on help your college applications. Now I will share their videos. Let's take a look at Tiffany. She's gonna introduce her experiences that she did at UCLA and then in different projects.
Hello, so hi everyone, my name is Tiffany. I just graduated from high school and I'm planning to attend UCLA in the fall. I do enjoy a lot of the arts besides biology and science, and I think that's what makes me in, I guess, a special position that I like to combine my artistic passion with science to do a lot of projects that I have in my life, as well as serving my community. So if you look at the left side, that's one of the it was the cardiac surgical internship I went to with Stanford. And that was different because we had a lot of hands-on work, and I didn't expect to learn so much from, I guess, outside the classroom. And it was very eye-opening in that we got to say like surgeries in simulation, and we had a lot of professors give us like actual lectures, and it was a very different format from high school classes, but I really enjoyed it. An active volunteer for American Red Cross. I think volunteer service or service in general is a very important part in my life because I always give back to the people who helped me, and I think doing service is the best way. So on the right side is a picture from when I was presenting with my summer internship at UCLA, which is what I'll focus on. You might be able to see that on the presentation screen in the picture. Those pictures are what I drew along the help with the researchers and the project I was focusing on. The front cover of this article was actually designed by me, and I had a lot of fun working with the two researchers who were the main contributors to this article, which is the first two co-authors on the listing. This format really helped me learn because I use my own skills, obviously, to contribute to their work. But in return, they taught me a lot about their specific article. This one was on Cas9, which is like about like gene transfers and specific in fixing a disease in the eyes. So with the communication back and forth, not only they benefited from, I guess, getting better quality images, which they had to explain to me all the concepts. And that way I learned so much more about the concepts, and I also put it out with art.
All right, so I think you just met Tiffany in this way. So Tiffany, she has a lot of passions, not only biology and then like to be a surgeon, but she's also interested in piano, ballet, and then arts. So as you can see from the video, she really used her talents in painting, drawing, and then contribute that talents to the medical usage. So actually UCLA hospital, they really like her drawing and they hand on her work in the hospital to show the patients, like explain the illness and then how does internal organs operate. So yeah, you guys can find your talents and your passions as well to contribute in different ways, and which is very meaningful for your personal growth and also for the community. All right, I will share the other video is Wellington, the one he went to Caltech and he was previous RUP president. So he's gonna share about why did he work with AEC and how did this experience help him to grow and learn, and then how did he apply the computer science skills into the service projects.
I did service before, but it always felt like I was doing it just for the hours, just to reach an hour requirement. I wanted to challenge myself and improve my coding skills during these service hours, and that is one of the reasons why I joined AEC. So how did AEC help me? Well, AEC provided a leadership opportunity. I became the president of Renewable Urban Pioneers and got to lead other students and do research in deforestation. To summarize what we did in Renewable Urban Pioneers, we published our research in a web journal. We hosted webinars with speakers from two nonprofits that are Rainforest Trust and Greenpeace International. And we also sold t-shirts to raise money towards protecting the Amazon rainforest. And on top of that, I was able to contribute while further developing my passion. I'll be majoring in computer science, and while volunteering in RUP, I got to practice and improve my Python proficiency while doing research. I did.
Yeah, all right. So this is Wellington. He shared about his experiments in the RUP. So that's pretty much about the sharing from the student side, and then also how Perceiver use holistic methodology to help students to grow and learn with different components, not only the schools, but also help students to apply for the summer schools, help students to apply for the internships, and then also we guide students to build a confidence to be a good leaders in different kind of service projects. Yeah, so if you are interested in learning more, like knowing about yourself, like maybe you don't know what's your strengths or weakness, you don't know what's the direction you want to go, or you don't know what kind of schools fit you, yeah, you're welcome to contact us, no matter with WeChat here or the email. So let me know if you have any questions. Do you guys have any questions from parents or student side? No? Very silent group. Okay, I see. So yeah, I'll just turn off the slides, but I'm curious, like anyone would like to share what did you learn through this summer camp? Anyone? Like, what did you learn through this summer camp? Like, except for the technical, technical terms, technical things, like in your like personalities or some soft skills. For example, like I know you guys, some of you are TAs, right? Like helping to the facilitators to teach. Wow, very quiet group. So you guys didn't learn anything on this summer camp? Let me see. How about Susan or Kathleen? Are you guys still there?
I can share. This is Wency.
Hi, Wency. Oh,
Hi.
Wency. Yeah.
Yeah, so I think this summer camp has been a really meaningful experience for me because I was the TA for Dr. Wyer's methane in groundwater team. And through my TA experience, I think I've really developed leadership skills by like organizing the meetings, sending out the class information, and like informing students for different announcements. And environmental wise, this summer camp really exposes like knowledge of methane and groundwater. To me, this is my first time actually learning methane and groundwater. So that was a new experience. And then yeah, I've learned different properties of methane. I've learned that methane is not that terrible, and like there's no actually drinking water standard for methane and like those stuff.
Okay.
Thank you.
Yeah, thank you, Wency. That is really great sharing. Not only your, how to be a leader, right? But also you learn a lot of professional knowledge and about the environment. Okay, how about others? Anyone would like to share? Yeah, today is the closing ceremony. So yeah, we really hope to hear what did you learn and grow, or what's your next step, like after today. What do you want to do more, or what do you want to learn more about the environment? How about Karina or Jason or Sean? Howard? Anyone? Oh, we have more people like Justine, Dory. Very quiet. Or any parents, if you want to like share, like what's your expectation, your kids to learn, and then what did you observe, what they learned?
I guess I can share a bit.
Okay, Justin, go ahead.
Yeah, I'm a senior, by the way, in high school, so yeah, pretty fun. But but I mean, I guess for our group, we went on a lot of different field trips. So yeah, I think I guess that's our group's specialty, because we have Dr. Peng. He works outside in OC and a lot of different projects. So he just basically took us on a trip. And and I think instead of being like a Zoom meeting, we got to go outside and because look out into the besides academics and everything, because I obviously have to handle a lot of other stuff besides environmental group as a senior, busy schedule, right? But yeah, I mean, it's good to go outside and learn about your environment, because it's starting to be more relevant right now in the 21st century. So yeah. So it's pretty interesting what our group did. I think that's all I have to share, I guess.
Okay, thank you, Justin. Yeah, I think one of the very valuable and then interesting part is you guys went to the field trip. And then I think especially now, COVID situation, people, no matter work from home or study from home, it sometimes feel disconnected, right? And also you don't have the chance to look at the environment you live. And then I think it's really privileged. Like you guys live in if you live South California, and you can learn with a group of people and then the experts. And I believe most of them make some good friends as well. Yeah. All right. Does anyone want to share? Yeah. Any word, anything, anything you want to share? Yeah, like I'm curious why you guys, you in the summertime, during summertime, you have so many different options you can choose. Why did you choose to join the environmental summer camp? Like what was your expectation, and then why you joined to, learn with these experts? Anyone?
I just want to say thank you. Thanks to all the teachers, coaches, professors, and staff. This is a great opportunity for students. As I can say, our students learned a lot. It's really very good for them. I appreciate that. Thank you all for your good job.
Oh, thank you, Jason. Yeah, we really appreciate you guys' participation, and then also all our experts, the advisors, and also our management team at AEC, Andy and also Wesley. They organized this event. They spend a lot of time coordinate, and then we just really want to make this summer camp really meaningful. We hope this is not just a one-time thing. We hope we can motivate students, have some curiosity, like, oh, I never I don't know about the water pollution or water usage. Like I don't have any idea about that. But after this summer camp, probably I kind of know more, and I want to, learn like deeper knowledge, or maybe I can take some actions, or maybe I can, connect more people to do more things together.
Yes,
So
maybe later on when the pandemic situation is getting better, we can have students visit some
yeah.
facilities like water treatment system, gardens, etc. Yeah, that would be
That'd be great.
better.
Yeah. Thank you, Jason. So, Jason, are you the parent?
Yeah, I'm a parent. Yes, Mark was parent.
Oh, okay. Thank you. Thank you. I think parents' involvement and participation is very critical. And then because if sometimes just, the parents need to demo the way, have people to help the kids to understand it's important. So thank you, Jason, as being a great parent.
My pleasure. Thank you.
Thank you.
Kelly. Thank you, Kelly. I think
I will hand over to Andy. Yes.
Yeah, our evaluation team, our judge team is already back to the main room. So I guess we already have a result. So exciting timing is coming. So let's share my screen. Hold on a second.
Andy, you're not showing our score screen, right?
Okay, wait a second. Okay, now is an exciting time to awards announcement. So first of all, we're gonna announce 3 judges' choice. So
okay.
It's your turn, Scully.
All right. The judges, we and myself, we all enjoyed the presentations. We are so impressed by the kids and the coaches' works. It's hard. You all did a great job. It's hard to really differentiate and tell which one is better. But based on the set of criteria, we evaluate you guys' work based on the topic focus and technical merit, originality, comprehension, effort and motivation, and your communication and team's coordination. So with that, I want to explain to the coaches the way that the sequence of the presentation, Andy decided that based on the sequence you turned in your material. So if you first turned in, you get to present the last, so you got more time to ferment on your thoughts. So that's a bit of explanation to the coaches. And now it's our announcement of the awards. We would like to present the most creative award to the emerging contaminants team, PFAS team by Dr. Jeffrey Hu. Let's have some applause to the kids and the coach. And then the next is our most aesthetic team by the Water Conservation California Native Plants and You, the second group. You guys designed the Japanese garden, and we think that's very beautiful. So that's the most aesthetic award. And then we have the most scientific award goes to the microalgae and water treatment group. We think that your topic is very, very scientific, very cool idea. Okay, so that's the 3 Judges' Choice Awards.
Thank you, Scully. Thank you, Scully. So next we're going to our, going to our gold, silver, bronze award to our groups. So we're gonna say who's gonna be the top, who's gonna be the silver, who's gonna be bronze. We're so excited to know. So Scully, who's gonna be announced?
Let's start with the bronze. We want to congratulate the Water Conservation California Native Plant and You, the first group. Yay, thank you, students and the coaches. You guys did excellent work. And we like the garden design, and we like how you connect the concept with the design and how you apply the concept. Okay, and the silver award goes to surface water management led by Dr. Peng Jian, Stella Shaw, and Jia Nan. You showed us the video and you shared with us your field trips, what you learned. We like the conceptual diagrams you presented in the PowerPoint. That was very cool, very professional presentation. And now our gold award goes to Methane in Groundwater team. That's some big applause to Dr. YR and
where's the drum?
Congratulations.
Congratulations, Methane Groundwater group.
Yeah, that was a very cool video, and we can tell the kids learned a lot and they had a great time. We want to thank all the coaches. We appreciate, we know that you guys all have your full-time job, you're busy, and we really appreciate your effort leading the kids to learn these concepts. I believe we put some inspiration and hopefully we inspired some future environmental scientists, engineers, or professors, and even maybe environmental lawyers. And with that, I'll conclude the award announcement part and goes back to you, Andy.
Congratulations to all the teams. So we really appreciate your dedication work and your presentation, a fabulous presentation tonight. So we hope you can enjoy your awards, and we're going to send you the official certificate later. So, and we'll thank you. Tonight will be over, and we thank you, appreciate the judges doing the work, and appreciate the coaches doing your past 6 weeks to do all the efforts you're doing for this summer camp, and doing all. And we wish all the students can continue to your researching and continue to your career, and you can do all the best wishes for you. Yeah, thank you guys.
We are likely going to have this again next year, so if you think the kids, if you like this experience, please spread the words among your friends, your family members, siblings. We hope to see some of your friends or yourself back next year. Okay,
yeah,
have a good evening.
We'll wait you back.
Thank you all the judges and coaches.
Thank you all to participating today. See you next time. See you next year.
Thanks our judges. Thank you.